Okay, in this particular problem, we're dealing with Coulomb's law. This is prototype problem 1. We have a charge plus Q and a charge negative Q. I give you the distance out along the x-axis, A, and the distance along the b-axis, or y-axis, B. What is the distance from charge Q to minus Q? Now, to get the best out of this exercise, pause the video and write down your answer. Of course, the distance we show in red, going from plus capital Q to minus small q, is the line shown in red, D, and that's simply the square root of a squared plus b squared. Now, what is the magnitude of the force on minus q? Pause the video and write your answer down. Of course, the magnitude of the force is KEQ parentheses minus Q over D squared absolute value. And we can write that as KE capital Q times minus Q over A squared plus B squared absolute value. What is the vector form? Or what is the vector from capital Q to minus Q? Of course, that is given by A I hat plus B J hat, noting that A and B form the components of the vector. Now, what is the unit vector from positive Q to minus Q? Pause the video, write your answer down. Now, of course, that is R hat equal to A over square root of A squared plus B squared, I hat plus B over the square root of A squared plus B squared, J hat. And both those, if I look at my angle theta, form cosine theta, which is the adjacent over the hypotenuse D, and the sine theta, which is the opposite B over the hypotenuse D. What is the vector force on minus Q due to Q? Now we're asking for the vector quantity of the force. And we can write that down as F equal to KEQ minus Q over D squared R hat. And we can go ahead and expand it to be KEQ of minus Q over A squared plus B squared times the unit vector. End of problem.